Let's take a look at problem 1020. That is from your problem data set, that I have posted on the web. Okay, and also this could be the one that is from your book that you are currently using. Okay, nonetheless, you can find the details of this problem from at either one of these two sources that I just mentioned. Okay, now in this problem we are given the data month January through December, the actual sales of a particular item. Okay, particular item. So that means we got the historical performance that we have over here. Now we have to begin to make the forecasting for the next year starting with January. Okay, continue that one. So in other words, we use the historical information to choose an appropriate forecasting method. So as you can see here, we'll apply the last value method to this data set, averaging method, then moving average method, and exponential smoothing. We'll apply 4 different techniques to this data, and then we will compare all those 4 based on mean absolute deviation, mean squared error, and MAPE. And we will choose this to discriminate between these 4 methods and see which of these 4 methods is the best method suited for this business situation. Then you choose that method, continue to do that, and as and when you make a forecast, you get the actual data available, then you compute the error, then plot the error on the control charts graph that I discussed in my previous lecture. So that's how you monitor the forecast. Okay, now what is the last value method? Last value method is, like for example, today is sunny. If it is sunny outside today, then what is the forecast for tomorrow? Most likely forecast for tomorrow would be what it is today. So that's the last value method. Last value method is what immediately preceded is what you can expect. For example, if I sold by the end of the day 100 units of a particular product, then my forecast for tomorrow would be similar to what it was today, 100 units that I sold today would be my forecast for tomorrow. That's what I would plan for it. Okay, so that is the most simplest method. That's last value method, also called naive method, N-A-I-V-E, naive method. So this forecast is same as what happened yesterday. That's the actual. Okay, 126. Then just copy the formula down, take it all the way, and this would be your forecast. The forecast for January of the next year would be 166. So what is the error? The error is the difference between the actual and the forecast. Remember, so now in this case the actual is more than the forecast, we get positive error. Okay, then in cases like over here, the forecast is bigger than the actual, 145 and 148, negative error. So positive and negative errors may cancel each other. So we want to end up with a situation. So we want, as I said before, both situations, either stock out or inventories, both are bad. So we go for the absolute values. Absolute value of the error. Okay, and error is the difference between the actual and the forecast. Then copy the formula down all the way to that. So in other words, the error is there only for those data points for which we have both actual and the forecast. Like we don't have the forecast here for January, neither we have the actual for the January of the following year. So they will not be considered into that. Okay, now what is the percent absolute, which is nothing but this one here. That divided by the actual. Now express that as a percent. If you express that as a percent, that's 8%. Okay, copy the formula down. There we get the percent errors. Okay, percent error. Now you can go back, and I think you can increase that to the decimal values if you want. Those are the percent errors that you get. Okay, now what is the mean absolute deviation? Mean absolute deviation, this is the formula that you use. This is the average of the errors, average of the absolute errors That is the command. Let's compute the mean absolute deviation. Mean absolute deviation is the average of all the absolute errors. Those are the absolute errors. That is that one. Average of that, which is 5.273. The mean squared error, that's the formula that we use, equal to the sum square of the range. The range is that. So it is taking each error, squaring that, so that is the square, then adding them up, that is the sum. That is sum square. Okay? And that is the total error. Now divide that by the number of error points, that gives you the mean absolute. Number of error points is nothing but the formula is count. Count the number of error terms that you have. Okay, so we give the same range. Count. 36.18. Okay, mean absolute deviation is nothing but the average of the percent errors that we have. 3.53%. What that says is, on an average, in this situation, either we were in stock out, about 3.53% of our demand was either stock out or it was in the inventory. Okay, one of those two situations. So that's what the mean absolute deviation is. Okay, that's the averaging method. Now, let us do that's the last value method. Now, what is the averaging method? Okay, the last value, if you look at it, 126 and 126 here. So meaning that, so in terms of the response to the changing market needs, we are quite fast with that. Okay, we are quite fast with that. Okay, but is this method suitable for this? May not be. We could be overreacting to the situations. Okay, so perhaps maybe a stable approach could be a better one rather than this. So in other words, last value methods is very applicable for those sort of demands that are more or less around mean and hovering above that, above or little by a little amount. Okay, so that's where the averaging method, our last value method is applicable. Okay. Next we will go to the averaging method. What is the averaging method? Now, in case of the last value method, we based our decision solely on only one value. So we could be overreacting to the situation. Maybe today's my demand could be high, but that could be anomaly. So tomorrow I might react to it by stocking up the same amount, but the demand could be half of what it was today. So I would end up with excess inventory, and especially if it is perishable, then I have to throw it. Okay. So averaging is not to react to this situation just based on one item, one value, but why don't you go and then consider what is the historical thing behind it. Okay, so that is the forecast. Okay, now the forecast here would be nothing but equal to the average. Okay, in other words, if I'm doing here, I'm taking the average of all the things that precedes this. In other words, the average of 126 is 126. But for example, if I'm here at this place, okay, my forecast is nothing but the average of all the previous things up to there. If I'm here, it's going to be average of all this thing up to here. So in other words, the January is where we will start all the time. Okay, so let's click that one and make it an absolute reference. That is a dollar and a dollar, comma. Okay, I'm going to just click it right there because that's the starting cell and that's where it ends, especially for February. Okay, close that, enter 126. But now copy the formula all the way down. If you look at it here, go ahead and click it at any point. It should start with all the way from there to there. Let's go and then let's fix this formula. This is the average of that column. This should not be there because we don't have anything there. MSE is equal to the sum square of the errors, divide that by how many terms. That's a count. How many? Count. That's a division symbol should be there. Count of the error terms. And the MAPE is nothing but the average of the absolute percent error, 6.59%.